A cube is resting on its base on the ground and one vertical face is inclined 30 degrees to VP. It is cut by a section plane perpendicular to VP, inclined 30 degrees to HP and passing through the top base corner. Draw the development of bottom part of the cube. Now observe the position of the cube. So for getting the development of the surface of the given solid, the first step is completing the projections of solids part. The second step is representing the section plane, and third step is drawing the development. In 3 stages you have to solve this problem. Now observe the position of the solid. A solid is something like this. Assume that this is the horizontal plane and it is resting on its one of its faces, something like this, and one face is inclined 30 degrees to VP. It is something like this, or this face is making an angle of 30 degrees to VP, and it is cut by a section plane. Now this is the position of the solid, and you assume that this is the section plane. It is cut by a section plane which is perpendicular to VP and inclined 30 degrees to HP and passing through this top base corner. That means it is something like this. The section plane is something like this. This is the orientation of the section plane. Now you have to draw the development of the bottom part of the cube. So now observe how to draw this. So first, initially we have to project the solid. That means complete the projections of solids part. So take the cube. When its cube is resting on the HP on one of its faces, this bottom face and this top face, these two faces I can assume as bases. So this is also a prism. This is a special case of a prism. This is called as hexahedron, which is made of 6 equal squares. So this top and bottom faces I can assume as bases. That means this base is on the HP, means axis will be perpendicular to HP. We will get the true shape and size of the base in the top view. So draw the top view. While drawing the top view, you have to keep one face inclined 30 degrees to VP. So here draw one 30 degree line. Along this 30 degree line, draw the top view of the cube, that is a square. So I am naming from this corner. Always you try to name from the left visible corner. That means from this corner I am naming, and I am naming in the counterclockwise direction, something like this. This is A, B, C, D. This is the top base. Bottom base also I will assume with the same names. So this is the top view. From the top view, project the front view. The next step, I am projecting the front view. Now I am drawing the projectors. Here side of the base is some 50 mm. So with 50 mm height, I am projecting the front view. This is A dash, this is B dash, because this B face edge is visible while I am seeing like this. So this is visible B dash. Next visible is this one, C dash. Now this D face edge is invisible. So in the front view, D dash is invisible. So if you mark the center point here, and if you project the axis will be somewhere here. So projections of solids part is completed. Next you have to represent the section plane. Section plane is inclined 30 degrees to HP and it is perpendicular to VP, means we have to represent the section plane with its VT. So in the front view we will get the section plane. That is the third step. Here I have represented this section plane. So after taking this section, here I am marking the cutting points. Now observe here, this is the section plane. This section plane is cutting this face edge A dash somewhere here. So automatically this is visible. I am marking this as 1 dash. Next I am moving in one direction and I am giving the names for visible cutting points. So with respect to B dash, I will get 2 dash because B dash is also visible. Next here it is a dashed line, invisible. So don't give the name to this. Move to the next visible point. So here this cutting plane is cutting this base corner. So here I will get the 3 dash at the base corner. When it is cutting the base corner, no problem. When it is cutting the base edge, then immediately you have to project that to the top view to get the corresponding points in the development. So here it is cutting at the corner, so it is not a problem. Directly you can locate 3 dash here. Now how to transfer all these points onto the development? Here for drawing the developments of prisms and cylinders, we have a method called parallel line method. So what we will do in parallel line method is you have to draw two parallel lines from top base and bottom base as shown here. Draw two parallel lines from top base and bottom base, and along these parallel lines you mark number of sides of the prism. Here it is a cube, means 4 sides will be there. So AB is one side, BC, CD and DA. All these 4 sides you mark along these parallel lines. Somewhere here I am starting. From here this distance is some 20. With 20 distance I have marked the second point B dash, next C, next D, next A. Something like that I am marking all the 4 faces of the cube. So if I bend all these 4 faces, I will get the lateral surface of the cube. Lateral surface means the part of the solid omitting the bases. Here top base and bottom base, if I omit, automatically by these 4 faces I can get a cube, lateral surface of the cube. That means these 4 faces I will get. I am omitting this one and this one. So lateral surface means all the surface of the solid containing only faces. Now so when the cutting point is on the face, directly you can transfer onto the development by drawing a locus line. Here cutting point 1 dash is on the face edge, so directly we can transfer. If the cutting point is on the base edge, then you have to transfer that onto the top view, and you have to take the corresponding distance from the top view and you have to mark here. Okay, so here it is not cutting the base edge, all the cutting points are on the face edges. So directly we can transfer onto the development by drawing the locus lines. Now observe, the corresponding locus lines are something like this. This is the locus of 1 dash. Here 1 dash point is on A. So automatically you transfer that point 1 dash as 1 onto the development on the face edge of capital A on the development. In the development we will represent all the corners with capital letters. Next 2 dash is on B. So draw a locus line up to the face edge B. Next 3 dash is at the corner C. So draw a locus line, and here C and 3 will coincide. Next 4 is on D. So draw a locus line on D, somewhere here we will get 4. So after D again we will have A. So on A we will get point 1. So what is the purpose of again taking A is, this is the side A. If I bend something like this, again this 4th face will come and join at A. That's why this first initial point A will get at 2 places, at the starting as well as at the ending. Now join 1, 2, 3, 4 and 1 with lines, something like this. Then this is the portion of the part of the cube we want. So remaining portion you draw with thin lines, the required portion you draw with thick lines.